Hey guys, I'm Dr. Pushpa. Today we are going to talk about acetylcholine synthesis. Okay, so how acetylcholine is made. Okay, these are the four things which we mainly need to know for this exam. Synthesis of acetylcholine and storage and release and action and inactivation. So these 5 steps we are going to read from this picture now. So I'll tell you how acetylcholine is made. To form acetylcholine we need choline. Okay, there will be choline. This is choline. Choline will be broken down from acetylcholine. Okay, so it is like a recycling process. Okay, from the acetylcholine the choline and acetic acid will be broken down. So this choline will enter into the presynaptic ganglion. This is presynaptic ganglion and this is postsynaptic ganglion. Okay, so from this acetylcholine goes here and it enters into the presynaptic ganglion to form again acetylcholine, to form this acetylcholine. Okay, so from here acetylcholine will go and choline plus acetylcholine. Okay, choline plus acetylcholine will form together to form acetylcholine with the help of this enzyme. This enzyme is really important, that is choline acetyltransferase. With the help of choline acetyltransferase, acetylcholine is formed. Okay, with this acetylcholine, after formation it will go and will be stored in this vesicle. Vesicle is nothing but it's a empty vessel. Okay, in this empty vesicle the acetylcholine after formation it will go and will be stored in the vesicle. Okay, after storage, whenever the stimulation happens, then this acetylcholine will be released in the synaptic cleft. This is synaptic cleft and it will act on postsynaptic ganglion. On postsynaptic ganglion there will be receptors. Okay, it just depends on parasympathetic and sympathetic. Acetylcholine, it is a neurotransmitter of parasympathetic. Okay, so if we are talking about parasympathetic, then the receptors will be NN and NM. Okay, and M1, M2, M3. Okay, these are nicotinic receptors and these are muscarinic receptors. Okay, so there's no confusion about it, right? So in this session we are just going to know the process of acetylcholine synthesis. Okay, so from here choline will be broken down from acetylcholine and this choline will be reuptake happens and it will be taken inside of the presynaptic cleft and this choline plus acetylcholine will form together and forms acetylcholine with the help of choline acetyltransferase. Don't forget this enzyme. Okay, so this after formation of acetylcholine it will be stored in the vesicle. Okay, this is the vesicle. Whenever the stimulation happens, whenever the parasympathetic stimulation happens, then this acetylcholine will be released in the synaptic cleft and it will act on postsynaptic ganglion receptors present on postsynaptic cleft. Okay, postsynaptic cleft, this one. So this is the process of synthesis of acetylcholine. Okay, now let's know about what all drugs will be inhibiting certain steps in synthesis of acetylcholine. We are just going to read about few main drugs. Okay, that is the reuptake of choline in the presynaptic cleft will be blocked by hemicholine. Okay, choline reuptake को block करने वाले हम है choline, that is hemicolinium. Okay, we can also call it as hemicholine or hemicolinium. The drug name is hemicolinium. The one drug is done. Okay, the next one is after formation of acetylcholine it will be stored in a vesicle, I said, that is this one. So the one drug which blocks the the storage of acetylcholine in the vesicle, that is the vesamicol. It is second drug. Okay, one we have studied, that is hemicolinium, which blocks the entry of choline in the presynaptic cleft, and then vesamicol is the drug which blocks acetylcholine storage in the vesicle. Okay, so that is vesamicol. Okay, then after we are going to read about botulinum. Whenever the botulinum toxicity happens, whenever the botulinum toxin enters in our body, it goes and it eats off this area. This area is generally for acetylcholine release. Whenever the stimulation happens, acetylcholine releases from this area. Okay, so this botulinum will eats off this area. Okay, which will lead to blockage of acetylcholine release. Okay, which will lead to blockage of acetylcholine release. So botulinum blocks the release of acetylcholine from the presynaptic cleft. This is presynaptic cleft. Okay, then first drug we have studied, that is hemicolinum, second one is vesamicol, and third one is botulinum, and the fourth one we are going to read about these four drugs. They are NM blockers. Okay, NM blockers, that neuromuscular receptor blocker, NM receptor blockers. They are antagonists of NM receptor. So these four drugs, they are alpha bungarotoxin and D-tuberculorin and atracurium and succinylcholine. These four drugs, they block NM receptor, which belongs to parasympathetic receptor. Okay, now again, first one is done, hemicolinum, which blocks the entry of choline in the presynaptic cleft, and the vesamicol is nothing but it blocks the acetylcholine storage in the vesicle, that is vesamicol. The name is matching, vesicle में block कर, vesicle में storage करने के लिए block करते vesamicol. Okay, next botulinum, it eats off this area, which will lead to blockage of acetylcholine release from the presynaptic cleft. And then these four drugs, they are alpha bungarotoxin, D-tuberculorin and atracurium and succinylcholine. These four drugs are NM blockers. Okay, and the last drug is this one, edrophonium, neostigmin and sarin. These three drugs will do the same action, that is acetylcholine esterase. So when I was telling you about the synthesis of acetylcholine, I said you, see, let's go to the last line now, so this one. So first choline will be broken down and entered into the presynaptic cleft, and this choline and acetylcholine will form together acetylcholine. Okay, and this acetylcholine will be stored in the vesicle, and whenever the stimulation happens, acetylcholine will be released. After releasing, it acts on the receptor. Till here we have studied, right? There is one more character I didn't tell you. Now I want to tell you, introduce you about him. That is acetylcholine esterase. It is an enzyme which breaks choline, which breaks off this acetylcholine into choline and acetic acid. Okay, choline and acetic acid. This choline will go back for the recycling process to form acetylcholine. Okay, so this acetylcholine esterase, see, don't get confused with this receptor. This is choline acetyl transferase. Okay, which makes choline and acetyl CoA will be converted into acetylcholine with the help of choline acetyl transferase. Okay, chat. Okay, so don't get confused between this and this. Okay, so acetylcholine esterase is nothing but it is an enemy of acetylcholine, that is acetylcholine को block कर देती है, that's why acetylcholine esterase. Okay, acetylcholine esterase, it breaks out choline and acetic acid, which this choline will be reuptaken into the presynaptic cleft, and that's it. So there are few more drugs which blocks acetylcholine esterase action. They are edrophonium, neostigmin and sarin. These three drugs which will do the same action, that is they blocks off acetylcholine esterase, which will lead to increased acetylcholine in the presynaptic cleft, in the synaptic cleft. Okay, increased acetylcholine in the synaptic cleft, because whatever the 100% will be synthesized, generally what happens, 100%, for example 100% will be synthesized in the acetylcholine. They are stored in the vesicle and they will be released when the stimulation happens. Okay, if there is acetylcholine esterase, ये 100% में से this will breaks 50% and 50% of acetylcholine will acts on postsynaptic cleft. But if there is no acetylcholine esterase, then there is no one to control this acetylcholine action. So 100% of acetylcholine which is made will act on postsynaptic receptors. Okay, so which will lead to increased sympathetic action, right? Okay, these are the drugs which will block acetylcholine esterase. Okay, they are edrophonium, neostigmin and sarin. Okay, so I'll just give a very short summary. Okay, so we are just going to talk about the acetylcholine synthesis. Okay, so choline will be reuptaken into the presynaptic cleft, and choline plus acetyl-CoA converted into acetylcholine with the help of CHAT, that is choline acetyl transferase. After the formation of acetylcholine will be stored in the vesicle. Okay, whenever the stimulation happens, the acetylcholine will be released in the synaptic cleft, and which acts on 50% of this acetylcholine which came here. 100% came, in that 50% acts on postsynaptic cleft and 50% will be broken down by acetylcholine esterase. Okay, esterase is an enemy because it breaks acetylcholine. Okay, acetylcholine esterase breaks off acetylcholine and gives off two things, that is choline and acetic acid, and this choline will be gone back in the presynaptic cell. Okay, now these are the 5 types of drugs we're going to read. That is hemicolinium, which blocks the entry of choline in the presynaptic cleft. Entry of choline को block कर देते hemicolinium. Okay. The second one is vesamicol, which blocks the storage of acetylcholine in the vesicle. Okay. This is the vesicle and this is acetylcholine. ये storage को block कर देते vesamicol. Okay. The other one is botulinum. Botulinum blocks the release of acetylcholine from the presynaptic cleft. Okay. And then alpha bungarotoxin, D-tubercularinium, atracuranium, and succinylcholine. These 4 drugs are NM blockers. Okay, NM blockers, which blocks the receptor NM, which will lead to, ye receptor is already blocked by these 4 drugs. Okay, N1 among these 4 drugs. So which will lead to the action of acetylcholine will not happen on NM receptors. Okay, so that's it. And the 5th type of drugs we studied about is edrophonium, neostigmine, and sarin. These 3 drugs will do the same action, that is the blocks of acetylcholine esterase. Okay, esterase is nothing but it breaks out acetylcholine and gives choline and then acetic acid. This choline, see, if this is blocked, there's no one to break down. The choline deficiency will happen later, but first what will happen? Increased acetylcholine in the synaptic cleft, which acts on postsynaptic cleft, which will lead to increased parasympathetic activity. That's it, guys. That's it. I hope you understood this, and any doubts, contact me through WhatsApp. Okay, this is my WhatsApp number, +790 400 62946. Okay, this is my WhatsApp number. Any doubts or any queries about any topic in pharmacology and or any other subjects, I'll make you easy. And thank you. Thanks for watching. I'm your Matrix Mata. I'll be taking the classes every Friday, Saturday, Sunday. So contact me through this number for any updates of upcoming classes. Stay tuned. Thank you.